Hi all, this is a continuation of Fourier integrals. Consider the second question. Find the Fourier integral representation of f of x defined as f of x is equal to 0 when x less than 0, 1 by 2 when x equal to 0, e raised to minus x when x greater than 0. Verify the representation at x equal to 0. So the first question is find the Fourier integral representation of the function f of x. First write the equation f of x equal to integral 0 to infinity a omega cos omega x plus b omega sin omega x d omega, where a omega equal to 1 by pi integral minus infinity to infinity f of v cos omega v dv. Here the interval is minus infinity to infinity. Here so we can divide this interval as integral minus infinity to 0 plus integral 0 to infinity. Here at x equal to 0 is a point of discontinuity. So we have to substitute f of x in these two intervals. In minus infinity to 0, the function f of x is 0. So here 0, and in 0 to infinity, the function f of x is e raised to minus x. But here we have to substitute f of v. F of x is e raised to minus x, then f of v is e raised to minus v cos omega v dv. Next, we have to integrate, use this equation, integral e raised to ax cos bx dx equal to e raised to ax by a square plus b square into a cos bx plus b sin bx. Here a equal to minus 1. In the place of x, here v, and b equal to omega. So substituting all these values and substituting the limits, we get the value of a omega as 1 by pi into 1 plus omega square. Next, b omega. In similar way, we can find b omega also. Substituting a omega and b omega, we get f of x is equal to this. One more question is the verify the representation at x equal to 0. So we got f of x equal to this, and substituting x equal to 0 in this equation, f of 0 equal to 1 by pi integral 0 to infinity cos 0 plus omega sin 0 by 1 plus omega square d omega. We know that cos 0 is 1 and sin 0 is 0. So substituting that values, f of 0 equal to, we get 1 by 2. Next, consider the third question. Find the Fourier cosine and the Fourier sine integrals of f of x equal to e raised to minus kx, where x greater than 0 and k greater than 0. We already discussed the definitions of Fourier cosine and sine integrals in the previous video. So substitute, first write the equations of cosine integral, then find a omega and substitute, we get Fourier cosine integral. In same way, we can find Fourier sine integral of f of x. Okay.